This video is sponsored by jlcpcb.com. JLCPCB is the largest PCB manufacturing company located in China. They provide premium quality PCB at an amazingly reasonable price of only $2 for 10 PCBs. You just need to upload your Gerber file and place your order. Now they have also cut down their price for 1 to 6 layer PCBs and stencils. Check out description for more info.
Hello everyone, welcome to the second episode of our ESP32 series. Now after watching this full video, you'll come to know how you can interface, or you can say how you can fetch the data of internal temperature sensor of our ESP32 board. No, it's not that easy. There are some issues with the internal temperature sensor that I will discuss in that video. Secondly, there is no example code available in the Arduino IDE for the temperature sensor. We have code for Hall effect sensor, we have code for touch sensor, but we do not have code for temperature sensor. So no worry, I'll be uploading that example code onto my GitHub account so you can easily download it and use that code. Now the second topic for the video is how you can use the PWM output on the ESP32 board. No, it's not that simple as compared to our Arduino boards because there is no support for the function called analog write. So yeah, we cannot use the function analog write to access the PWM pins. Rather than we need to use, or we need to declare some extra variables and use that variables to access the PWM pins. So in this video, I'll be talking about that also. So let's get started. So yeah, first of all, let's start with the internal temperature sensor code, and I already opened that Arduino IDE. So here is the internal temperature sensor code. I got this code while searching on the internet regarding the internal temperature sensor for the ESP32 board. So I'll be uploading this code onto my GitHub account, and its link is available in the description of this video. So let's start with the code. So the code says, the first line of the code says extern C. Now what is this extern C? I think most of the viewers are not familiar with the extern C. Rather, I was also not familiar with this function until I studied about this particular code. So let me explain this extern C in brief. First of all, let's read the comment which I have written. Extern C is used when we are using a function written in C language in a C++ code. Now let me clear one fact. Arduino language, or the code we are writing in the Arduino IDE, is based on C++ language. It is not based on C language. Okay. So what extern C function says, if we want to use any function which is written in C language in a C++ code, then we need to use extern C. Let me clear it. Let me make it very simple. Arduino IDE is based on a C++ language. Got it? Secondly, this function, which is temperature underscore sense underscore read. Now this particular function is must or is required to access the internal temperature sensor. But the problem is this particular function is written in C language. So if we want to use this particular function which is written in C language in the Arduino IDE, which is supported or which is written in the C++ code, then we need to use an intermediate called extern C. Now after writing this particular function under the bracket of extern C, the compiler comes to know that whatever is under this bracket, this particular code should be compiled according to C language, while the rest of the code should be compiled according to the C++ language. So this is the basic function or basic use of extern C. I hope your doubt regarding extern C must be cleared, but still if you have any doubt, I will be attaching one link in the description of this video. You go and watch that video because I too learned about that extern C function from that video only. So I will definitely suggest you to watch that video, as that video is really very helpful if you want to learn in detail about extern C. So okay, moving ahead. So we have declared one function called temperature sense read, which is in the C language. Okay. After that, we have closed this bracket and we have again declared, because we want to use this function in the C++ code also. Okay. So after that, void setup says serial.begin 115200, which is pretty simple. We are just beginning a serial monitor at a 115200 baud rate. After that comes the loop says temperature in degrees Celsius, so we are printing the temperature values in degrees Celsius. After that we are printing the values which says temperature underscore sense underscore read. Okay, this particular function will return the temperature value in degree Fahrenheit. Okay, so we have attached this, or we have applied this formula to convert degree Fahrenheit to degree Celsius, which is temperature in degree Fahrenheit minus 32 divided by 1.8, which gives a temperature value in degrees Celsius. So this is the simple formula for that conversion. So after every 5 seconds we will be getting a new temperature sensor data. So this is it about the code, but still there is the issue. Let's first upload it and then I will discuss about the issue. Okay, so I will go into tools, select the board which is ESP32 dev kit, which is already selected. The board is also selected here. Okay, we'll just click on this upload button and I need to press and hold this boot button. If you don't know why I need to press and hold this boot button, kindly watch out my first episode of this ESP32 series. If you don't press and hold this boot button, the code won't be uploaded. Okay, so now just we need to press the reset button and our code must have started. So just opening the serial monitor. Okay, so we are getting temperature in degrees Celsius is 53.33. Now let me zoom it in. Okay, so what's the issue? See, I have 3 ESP32 boards with me and I have uploaded this particular code in all 3 of them and I got same result, which is 53.33. No matter how much I put it under a sunlight, no matter how much put it inside or near to a cold water bottle, the temperature value remains constant, which is 53.33. I also googled about this problem and many of the makers or many of the engineers are facing this kind of problem. What they have said is still ESP32, the internal temperature sensor of the ESP32 is still not compatible with the Arduino IDE and hence we are not provided with the example code. While some of the makers, I also watched one video in which a person is uploading code from Arduino IDE to ESP32 board, the same code is uploaded and he is getting the variable temperature value. He told that the temperature value is not accurate, but still he is getting a variable temperature value. But in my case, I'm getting one constant value only. So it's a big question mark for me also, as all 3 of my board are giving the same result. But still, I will leave it to you. Just download this code from my GitHub account and upload it onto ESP32 board and share your result with me in the comment section of this video. I want to know that do everyone is facing the same problem, or do everyone is getting the same value, or you are getting a different value. So do let me know in the comments below. So this was the issue with the temperature sensor. Still I gave the code. You can easily access that code from my GitHub account and just download it, use it and let me know the results. Okay, so let's move on to the next topic of today, which is the PWM pins of the ESP32. So I already written one code. So here is the code to access or to use the PWM output of the ESP32 board. Analog write is not supported, as I already told in the starting of the video. So let's just start with this code. So this code starts with the 3 variables, which is frequency, LED channel and resolution. Frequency is a pretty common term between engineers and makers. Still I have commented frequency means the on off timing cycle. So in 1 second the LED is turning on and off for 5,000 times. Okay, so this is the frequency. This is variable. You can change this frequency. Okay, so next is the LED channel. So there are 16 different channels available in the ESP32 board. We can use each channel for interfacing PWM at different pins. So one great thing about ESP32 is we can use the PWM output at any GPI of ESP32 board. Let me show one page. So I'll be attaching the link in the description for this particular page. This page is very helpful for getting details about different pins of our ESP32 dev kit V1 board. Okay, so for the PWM, I don't think it is mentioned here or not, but still. Okay, so here is the thing. The ESP32 LED PWM controller is 16 independent channels that can be configured, generate PWM signals with different properties. All the pins that can act as output can be used as a PWM pins, which is GPIOs. There is one restriction: GPIO 34 to 39 can't generate PWM. Rest of all the pins we can use as a PWM output. That's a great feature of this ESP32 board. Okay, so let's just move back to the code. So we have 16 different channels to make different properties or different kind of PWM outputs. So I selected the LED channel 0 for this example code. We can go up to 16-bit resolution, but this time I have selected the 8-bit resolution. Why I have selected the 8-bit resolution? Because it is pretty common. In the Arduino, we are familiar with the 8-bit resolution only. As you must be knowing, if you have used Arduino, the values for the PWM in the Arduino goes from 0 to 255 because that's the 8-bit resolution. So hence I use the 8-bit resolution here, but you can also select the up to 16-bit resolution. Okay, so I interface one second PWM pin also, but first of all I will see this channel 0, and after that we'll also uncomment this and we'll see the output at channel 1 also. Okay, moving ahead, in the setup part we have one function called LED C setup. In this particular function we are just initializing the particular property or particular characteristic of the PWM to particular channel. For example, here we need to write the LED channel number, which is a 0 in this case, then the frequency we need to mention, and on the resolution. So this is basically setup part, or we are just providing the properties of how the PWM wave will be. Okay, so this particular function or this particular properties will be assigned to LED channel 1, which in LED channel, which is the channel 0. Okay, so after that we have to attach this particular channel to a particular pin. For that we have function called LED C attach pin. So I have attached this LED channel which is 0 to pin number 2, which is GPIO2. So we can directly write GPIO2 as 2. So this is the setup which you need to do. After that we come to the loop. In the loop we are just, it is very basic or it's very simple task. We are just incrementing the numbers from 0 up to 255. Why 255? Because it's 8-bit. If it was a 10-bit, we will be incrementing the values from 0 to 1024, or we can say 1023. Okay, so you are just increasing brightness in this particular case by a function LED C write, in which we need to provide the channel number, which is 0, and the the integer value which need to be stored in that particular channel. So the values will go from 0 to 255 with a delay of 5 millisecond, and after that the values will go from 255 to 0 with again a delay of 5 millisecond. So this is basic example. It will, the brightness will increase, and after that the brightness will decrease. So yeah, this is the code if you want to use the PWM pins of the ESP32 board. I have attached one LED on the breadboard along with the ESP32 board. I made the connections. So I'll just upload this and we'll have a look at the result. Okay, so I'll select the board which is already selected. Just click on this upload button. We'll press and hold this boot button. Okay, so it is connecting. Okay, started uploading and it's uploaded. Let me just zoom it in. Then I press the reset button and I think it is visible. I think now it's visible. Okay, so the bright increases and increases, decreases, increases and decreases. So this is the PWM output on the ESP32 board. Now let's just configure quickly the channel 1. As this is a bi-colored LED, I will attach the red color of this particular LED to channel 1, and the green color is already attached to channel 0. So I'll just skip this particular portion in which I will be uncommenting the already written code. Okay, so this is all about the code. I have attached the channel 1 to the red color of this LED. I will just remove the connection for green LED and I will see the effect of the change in the frequency. Okay, I will just click on this upload button. We'll press and hold this boot button. It started uploading and I think it's done uploading. Okay, I'll just remove the connection of this green LED. Let me zoom it in. Okay, so it will stop and okay. As you can see, it is blinking, which is the blinks are noticeable, while in the case of green LED the frequency was 5000, so the on and off time was not at all noticeable. Okay, so this was the effect of change in frequency. So likewise you can make 16 different channels for 16 different kind of PWM. So yeah, so this is it about the PWM output of this particular ESP32 board. So yeah, this is all about the episode 2 of the ESP32 series. I hope you got the idea about how you can fetch the temperature sensor value from the ESP32 board. I also provided the code for that, and you also learned about how you can use the PWM pins of the ESP32 board without using the analog write function. So yeah, this is it about this episode. I hope you find something interesting, something informative in this video. If yes, then do give a like to this video. Subscribe my channel if you want to learn more about the ESP32 board and also about the projects on IoT, automation and electronics. So wait for my next project. Until then, explore, learn, share with me, techiesms.